We want to talk about quadrilaterals. In a parallelogram, for instance, we mostly find quadrilaterals over there. That is the only place that we find the quadrilaterals angles when it comes to issues of angles that are going to be formed by opposite sides, which are equal and parallel as well, and also opposite angles. Then they are going to be parallelogram. So it is from the parallelogram where we find the quadrilateral. We have said their characteristics are very few. Number one, it has opposite side. So it has the first side and the other side. If it has this side and yet has the other side, that is all about angles. It has also more about the lines. And then if the angle, for example, let me talk about the angle first. The angle, for example, if you're talking about the upper angle and the lower angle, they are going to be opposite and they are going to be equal. And then let us also talk about the issue of the line. This line and the other line, they are going to also to be equal. That is the secret of this thing we are introducing here about quadrilaterals, which is being formed by a parallelogram. Three things are only found there in parallelogram. The first one is a square. The second one is a rhombus. And the third one is what? What?
A rectangle.
A rectangle. That is the only third thing that is formed there. In page 40, blessed people, page 40 of the new revised syllabus, mathematics textbook, class 7. So I want to introduce to you to parallelograms in a short while. And I want to say this way. Activity 1. Measure line QT and RS. What do you notice? Can you read for us, B, Ian?
Measure angles QRS and RQT. Find the sum of the angles.
What do you notice?
What do you notice?
Line QT and RS are equal and parallel. First of all, as you look on that diagram, the diagram, it is a diagram that is bringing itself in a way that is clearly, absolutely a robust. That one everybody can see. And I will say this way, that its angles are equal and sides are parallel and also equal. Then in number 2, we have A, measure line QR and TS. What do you notice, my son? There is something you're going to notice, that line QR and TS are what?
Equal and parallel.
Are also still equal and parallel, as you have said here. And then from there, I say this way. In number 3A, measure angle RQS and QTS. What do you notice? B of it. What does it say, my son? The question alone.
Measure angles QRQT.
Measure angles RQ what?
T.
And what?
And RST.
And RST.
Find the sum of the angles.
Find the sum of the angles. Sum of the angles. What do you notice again? And I say this way. The quadrilateral. Everybody write this. This is a beautiful point to write. The quadrilateral. The quadrilateral. Let's write. The quadrilateral. The quadrilateral. QRST has opposite side. Has opposite sides. And then I also say equal and also parallel. As opposite sides, equal and parallel. Equal and parallel. Equal and parallel. And then I say this way, and opposite angles which are also equal. And opposite, we can use angle QRST. You can also use angle SRQ. You can use whichever angle you want. You can also use angle SRQT. You can also use RQTS. Which another one can you also use, my son? You can use the way you want. You can circle it the way you want. You see that? Then I say this way, that the quadrilateral QRST has opposite sides, has parallel lines, and has opposite angles which are equal. That way, it is a parallelogram. It is a what? parallelogram. So parallelogram has three things. The first one has is what, my son? Talk to your people on the camera now. One thing it has is what? It has what? Its opposite sides are equal. My other learned fellow here, what have you understood?
Yes, sir. The opposite sides are equal and parallel.
The opposite sides are equal and parallel. I've said that this way, it is a parallelogram. That way is how I want to introduce to you in the mathematics that is coming up very shortly while here. We want to thank you for being with us and for tuning in for us. We can wave to them. Thank you so much.